All right, in this section here, we're going to start talking about normal distributions. So to start looking at that, we're going to look at the problem of the day. It says students on a field trip posed for a group photo. What's the percentage of students' heights within one standard deviation of the mean height? So a lot of students saw some key words here. They said standard deviation and mean. So they started saying, does it mean stand for average? Yes, it does. They said that you add all these numbers up and divide by the count. I said, yeah, you can do that. But believe it or not, you can actually take your scientific calculator or graphic calculator and throw this list in, and it'll do all the work for you. So let me show you how to get to that right now. So if you're on your TestNav program, you go down to your tutorials and launch your calculators. And this time of year with code tutorial start, and on there you will see your scientific calculator. So like the ones in class, this is the one that will do that. So what do you do on this calculator is you'll click on data, and then all you got to do is start typing those numbers in. 59, hit enter, 60, and so forth. So I'll come right back and I'll have all this data entered, and then I'll show you what we need to do. Once you get all the data entered, as you can see, it says 36 here, but if you go up one, there's 35 pieces of data here. So in this graphing calculator, if you hit second and your data button to the stats, hit the one variable stats, and then everything should already be set up for list 1, frequency 1. Just go down and hit calculate. Then you're going to get a list of information here. One, you found out there's 35 pieces of data. Here is your mean, the X with the bar over it. And then there's actually two different types of standard deviation here. The difference between them is this. S stands for statistics samples, or that's that with standard deviation. The little symbol here, with like a little whippy sign off the end of it, that is the population. So parameter population, which makes that like a sideways P. So if you can remember those key words, you'll know which one's which. Normal distributions usually use the population one. If you go on down your scroll here, you got the sum of all those numbers added together, the sum of all their squares. You also have what's called the start of your 5-number display, which is for a lot of you will recognize as a box and whisker plot. So if you looked at a box and whisker plot, your left whisker would be 59, which is the minimum. The left side of your box would be 65. That's also called quartile 1. Quartile 2, or the median, which you're more familiar with, which is the line that's usually in the box, is 67. And then quartile 3 is 69, which is usually the right end of the box. And then the max is usually your right whisker. So a lot of this information is there. Now remember, if you have outliers in your data, remember the mean doesn't work, and neither will the standard deviation. So you'll have to go to this backup, which will be the median if you need to. Remember, the median is the middle number, or the average of the two middle numbers. And then, believe it or not, the backup for not being able to use the mean or standard deviation is what's called interquartile range. And that's where the Q3 and Q1 come in play. Subtracting those from each other, that's its backup when you cannot use it because of an outlier. So that's some information you can do. You can also do the same thing with this in the graphing calculator. You just hit the stat button. Once you hit the stat button, you can hit edit and get your list to punch in, and then once you hit the stat button again and go over to calculate, you can find the one variable thing there. So here's our information. We know for our problem, since y'all said we need to find mean is 66 or 67 is what it's going to round to, and our standard deviation is roughly 3.6 between these two. So we know some information here. Y'all said N was 35. The mean was rounded to 67. And the standard deviation, which in this case you use the S or this technically we use the S, it will round to 3.6 for the most part on things. That's what we're going to say is standard deviation for this. Now, to answer this question, here were the two most popular answers people said. They said, okay, let's just add 1 and subtract 1 from the mean and then do our count in there, which means it means they say range it between 66 and 68 and do a count in this data to answer this question. So they said count everything with 66 and 68. So that was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 out of the 35 is what some people said was the answer to this question. Others said, wait a minute, no, that don't seem right. Maybe we need to add and subtract 3.6 from this. So they did 67 plus or minus 3.6, and which means they ranged it from 63 to 71 for the most part. So they took all these numbers, but they went in and says, hey, let's go ahead and include 63, 64, and 65, and then go ahead and include 69s, 70s, and the 71s. So the count on that increased it to quite a bit more on things, which means you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. They're saying, hey, so it's roughly 27 out of the 35. Or some people said even down to just 70, or just do 70 and 64, which got it down to 24, to see if this gave it a closer number on things. So either way you could look at it, you can look at this as a possible answer. I will say this, one of these is correct. So let's grab some data information about this section about normal distribution. You've actually, if you've got in AP Bio, you have seen the normal distribution curve and so forth. So let's talk about this. Mean, in our calculator, it's always represented as this in both calculators, but on paper, it's a U with a tail on it. It looks like this. Remember, it's just the average of all the numbers. On median, we've already talked about that, the middle number or the average of the two middle numbers, depending on if you got an odd or an even amount. So this has 35. The median on this one is 67. Standard deviation, that little symbol for normal distributions is this symbol because it deals with populations, parameters and populations. That's how you remember which one to use. And then technically you have already seen what's called the norm distribution curve. It's the bell curve, folks. Y'all have actually seen that. When somebody refers to this bell curve, they're referring to this thing. So you have seen this. A normal, and it works in such a way to where the mean is always the center of the curve. So in our case, the 67 would be the center. And if we're adding and subtracting standard deviations, look, it says standard deviation, so that 3.6 is what you would use. So it means if you go up, you get 70.6 here, 74.2 here, and 77.8 here. And then coming backwards, downward, you get 63.4, 59.8, and 56.2. These numbers will always change on this graph based on your mean and standard deviation you're given. The things that won't ever change on this graph are the shape of it and where these things are located and their percentages. The normal graph just gives you these three, but if you will remember this little trick, split your 68 into a pair of 34s. These two sections out beyond this are both 13.5. The next layer, this section here, is 2.35%, and so is this one. And then the last chunks out the very end are always 0.15 and 0.15. So this all adds up to be 100%. So these are things, if you'll simply remember to do this, even on the EOC, it will help you greatly when you're answering the questions. So if they start asking you questions about what percentage of people are in ranges of these, all you have to do is find the numbers that are contained in here, and you look at the percentage blocks right above there and basically add them up. So that's what you need to do. So this part never changes. Only the numbers below will change. So what I would like you to do right now, based on that, is go ahead and make out two of these for yourself, for example, one, and they do give you two means and two standard deviations based on male and female, which means you've got to make two of these. So go ahead and make an example of this and go ahead and fill in what the numbers should be on the bottom. I'll come right back in a second. Pause it now. You can check it in a minute when you get this done. So if you did this correctly, here are the numbers you should have. The means for the male should be in 85 in the middle, female should be 48 in the middle, and then on the males, you add it 9 to each time and subtract it 9 each time to get the other numbers to the left and right. Same thing for the female. She had 6 as the standard deviation, so you add it 6 both ways and subtract it 6 both ways to get to those numbers. So use this to answer the questions. First question is asking, how can you use this rule for the male mountain lions to figure out how many percentage of how many lines are between 67 and 103. So it's wanting the male ones. 67 is right here. 103 is right here. So you can do this two ways. You can add 13.5, 34, 34, and 13.5. Or if you're slick enough and can understand the top numbers, you know it's between 95%. These will add up. So 13.5 plus 34 plus 34 plus 13.5, that winds up being 95%, and that lines up with our markers. For the second question, it says go to the female ones, and it says between greater than 36, less than 54. Well, 36 is here, 54 is here. You still got your same amount here. So it's got the 13.5, 34, 34, and 34. It's just these three items. So you need to add those up. So 13.5 is where the 36 starts. Then you got a 34 and another 34% there. So when you add those up, simple calculation, you get you basically get your answer here, which is 81.5%. And then answer the last question. It says, how do you determine the percent of female lions who study weighed more than 54? So the more than 54 is going starting here. That clicks 13.5, 2.35, and 0.15. And when you add those together, you wind up getting exactly 16%. So that's how you use the normal distribution curve usually to answer questions on these. And that's it. On your formula sheet, you do the same thing. They won't have all these individual numbers. They'll have the big numbers, the 68, 95, and 99.7. So if you remember these numbers, you are allowed to write them in as soon as I hand you that sheet. All right, the second half of this lesson is what we call a z-score. Z-score changes the normal distribution curve to where the middle is 0 and it's plus 1, 2, 3 and minus 1, 2, 3 on the back. It gets rid of all the units and all the numbers. So the norm curve itself looks kind of like this, and 0 is in the middle, and this is plus 1, plus 2, and plus 3. And this is minus 1, minus 2, and minus 3. And the reason why you want to do that is it helps you figure out what's called good data and extreme data. Anything outside the plus 2 and minus 2, if it's further to the right of plus 2 or further to the left of minus 2, it's considered extreme numbers when you're testing stuff. And it's a simple formula on your formula sheet. It uses this one right here. All you literally do is just plug in. That U is still the mean. This is still the standard deviation. So all you literally got to do is plug in your number and do that thing. So if you're looking at this mechanic car on this engine cover, they give you the mean is 2.5, standard deviation is 0.1. You already have those parts given to you. So you know it's 2.5 minus, and the standard deviation is 0.1. And then they're saying check the 2.18 score. When you do that, you get all this calculation. You do the top part first, get an answer, and then divide by 0.1. You get a score of negative 3.2. There is no units. The centimeters have disappeared. So your z-score is negative 3.2. And they said they're going to reject it. Well, why? It's way out past the negative 2 mark. It's actually beyond the negative 3. It's in that 0.15% range of bad. So that's what a z-score does for you when you do it. It's a very simple calculations, and for interpretation purposes, it tells you where the things are good. Things are good between negative 2 and positive 2. Things wind up going extreme on both ends on this. Negative means below a standard deviation below. So a z-score is a form of standard deviation. So this is 3.2, negative 3.2 is 3.2 standard deviations below. If it's a positive, it's a 3.2 standard deviations above. And so an example of this would be children, how they just do pediatrician's office. They usually use this data type of stuff when they talk about kids and where they're at. All right, everything on your assignment is to be done. I would write these numbers in just like I did in the example. You just pull the numbers and do your percentages. On the z-scores, You just need to find a z-score for every number here. So which means 11 and 12 have two z-scores, 14, 15, and 16 have two z-scores. And that is what we call normal distributions, which means up top the orange ones were correct on the problem of the day.